Hi everyone, this is Louise. Um, Not really here today, but this is a recording of my voice. And right now I'm in Atlanta, Georgia. Um, and I couldn't be with you today. I am really excited about this next unit though, and let me tell you a little bit about it. The theme of this unit is colors are not what they seem. There's a lot to cover, but it's all going to make sense as it comes together. So here we go. If any of you are interested in color optics, this is going to be an awesome unit for you. And there's more to color than meets the eye. And this is a really great example of color optics. If you first look at it, you might think, and you try to count all the colors, you might think that there are four. There's like pink magenta, a dark magenta maybe, a green, and a white. But what's actually going on is that there are three colors, and that would be magenta, white, and green. Why is that? Because magenta is near the green and the stripe going from the bottom left corner to top right is perceived by the human eye differently than the magenta that's near the white, to be perhaps darker or more of a reddish tint than the violet or the pink. So, seemingly unrelated, but this handsome fellow is Michael Eugene Chevreul, and he was an important figure in color proximity or color optics. And what he discovered is that color is in part a psychological phenomenon. The last slide was a perfect example of how color proximity, or how close colors are to one another, can really change the perception of how you see that color. So, Chevreul was a French chemist during the 19th century, and he researched many things, but he was well known for his experiments with color proximity or color psychology. The last example has only three colors, but psychologically in our minds we see four. And that's just one example of how the brain works. Why is that? The reason Chevreul became interested in this phenomenon was through his time at the Gobelins Tapestry Works, and this was a carpet manufacturer. He became really frustrated with the way colors or dyes that compose the image on the fibers never seemed to be consistent. And after messing with the dyes a bunch and the chemical properties of the dye, he came to the conclusion that the chemicals were fine, but the color relationships are what is changing how a color is seen. This was what led him to write The Principles of Harmony and Contrast of Colors in 1854. Simultaneous contrast is a term coined by Chevreul, which refers to the way colors interact with and affect one another. So if you thought that every color you see is how it is in reality, then I hate to burst your bubble, but it's not true. This GIF has several examples of simultaneous contrast. And the typical example compares a small shape of color that's surrounded by two large background fields of color. The inner shapes are primarily what we're focusing on, and the larger shapes are being used to change our perception of them. The total surrounding of another color along all of the edges of that smaller shape is what ensures the greatest change in the color illusion, or the more they will have the ability to affect one another. Joseph Albers is more likely someone you're familiar with, or have heard of him at least. He's one of the artists we'll be looking at his work in the print study room at the ASU Art Museum, which is going to be really cool. I remember when I was learning the same thing and I got to see his screen prints in person. They're very beautiful. Albers was a German artist working primarily in painting and printmaking. His other love was teaching color theory, and he's been extremely influential in the field, so that's why we dedicate a whole unit to him. He was a professor at the Bauhaus School of Art and Design in Weimar, Germany during the early 20th century. He was the one who designed the famous example of simultaneous contrast from the last slide. After experimenting with the most effective way to show this phenomenon to his students, he came up with that. So, color interaction is another term we can use, a more broad term, for the phenomenon of color illusion. The definition from the book reads as this: a color illusion that occurs in our perception of color due to the interconnected relationships of colors, most notably explored by Joseph Albers. And this illustration is from his series called Homage to the Square, which we will have the privilege of seeing in person. There are three principles of color interaction. The first is light-dark value contrast. The second, complementary reaction or effect, and 3, subtraction. But don't worry, we'll get into lots of details and visuals here. So the first principle is light and dark value contrast, and this is the one that's most easy to understand right away. So, in general, colors appear lighter when surrounded by a dark color, and colors appear darker when surrounded by a light color. This example down here is pretty dramatic. The two inner squares are actually the same shade of purple, but how do they look different? Well, one looks lighter and one looks darker. So the inner square that's surrounded by the light purple is appearing to be a very dark purple, whereas the one on the right is very light. Subtraction is a little bit more difficult to understand, but this is when a hue is being changed by a surrounding background color. And this is usually easier to see at full saturation. So these are all full saturated colors. The inner square is red-violet, and one red-violet square is surrounded by red, and the other one is surrounded by violet. And the red-violet that is surrounded by red appears to be more violet, whereas the red-violet surrounded by violet appears to be more red. Now this is happening because our eye wants to see the complement of a color, meaning that it wants to seek balance by seeing the opposite. So subtraction is the easiest to understand in terms of an equation. So when that red-violet is surrounded by red, it's subtracting or taking away from the red nature of that color. So RV, or red-violet, minus R, red, equals violet. Red-violet minus violet on the right side is red. Complementary reaction is similar, and this is also because the eye is wanting to see the complement or the opposite of a given color. So here's an example of the same orange, one being surrounded by gray and one being surrounded by a fully saturated blue color. So the blue is bringing out the more saturation of that orange, so it appears to be more brighter to the eye, whereas the gray is dulling that saturation of the orange and kind of taming it down. The best way to understand how our eyes are actually wanting to see the opposite of a hue is in the next example. And so this is good for us because otherwise our eyes would be very tired. without this balance going into effect. This is a pretty famous painting by Jasper Johns called The Flag. So what you're supposed to do is look at that inner white dot for 30 seconds. Almost there. Okay. Now, stare at the black square. What do you see? Ooh, some showing up. For me at least. Our eyes are actually a natural Photoshop adjustment of inversion. You know, when you invert the colors. So this is an inverted American flag. This is what our eye naturally does to give ourselves some balance. So this is also what's happening when you're looking at those examples on the slides I was showing you before.
Someone who is also influential to color theory today is an artist named Anni Albers. Anni was married to Joseph and was also involved with the Bauhaus School in Weimar, which is where they met. So at the time, women were only allowed to study certain gendered crafts, which was very frustrating at the time, but she enrolled in the Fibers program and luckily she fell in love with it. This is Anni at the loom, where the threads are weaved together for her pieces. Not only was she a textiles artist, but she was a designer, printmaker, painter, and an educator. After the Bauhaus School was shut down by the Nazis, Anni and Joseph moved to the United States, where they both enjoyed very successful careers. You definitely don't have to be a textiles artist to enjoy her work. She often would create an abstract painting, planning out the design and colors of her tapestries before taking them to the loom. So later, when she started working on printmaking in the United States, her work really translated well to paper, and she always kept her unique gridded style. Anni was one of the pioneers in the study of optical mixtures, which are tiny amounts of colors that are blended together, which our eye visually blends into a new color. And weaving is a really great way to use this effect because the threads are so small, but it is commonly used in many different kinds of mediums. Devorah Sperber is a more contemporary artist who also uses optical mixture. In fact, this work cannot be understood at all without background knowledge in optical color mixing. She's well known around 2010 for recreating famous art historical images with spools of thread. So by looking at the spools through a lens, the image is flipped the correct way and the edges warp. So that because the image seems smaller and farther away, we actually get the optical illusion of the Mona Lisa. The Bezold effect is another easy effect to execute. This occurs when changing a dominant color of a composition, in this case magenta. The look of the piece will change dramatically. So this is something you can do just with colored paper as well. So cutting out stripes and then pasting them to a colored background and then putting another piece of paper underneath it. That's the Bezold effect. Complementary vibration is one of my favorite color illusions, and it looks really trippy, literally. Complementary vibration is an illusion that occurs when two full saturation complementary colors create the illusion of movement. This example is a psychedelic band poster from the artist Wes Wilson. The artist Wes Wilson was the inventor of the melting font used in many posters or band merch that we see today, mostly psychedelic rock or metal.
The complementary vibration along with the warped font creates this woozy feeling for the viewer to give the impression of an altered state. Wes Wilson is considered the godfather of psychedelic band posters. He worked primarily in the 1960s, or at least that's when he was well known. He was an employee of the Fillmore in San Francisco, which was a music venue for lots of bands. And his influences weren't just the counterculture or the hippie culture of the 1960s in rock and roll, but he was also really interested in the aesthetic of Art Nouveau, which was a movement in the early 20th century, as well as wallpaper design. So he made band posters for really famous musicians such as The Doors and the Grateful Dead. And this is a picture of him up in the